So now, this method that we're talking about here is graphing. So you're going to graph your two lines. If they meet in one, if they two lines cross, how many points do they meet at? One. So there's one solution. What if they're parallel?
0.
Yeah, they don't meet, right? So there's no solutions. What if they're the same line? Remember those? Where we had one line, the other one drew right over the top of it? How many points?
Like one.
A lot. What's another name for a lot?
One.
How about infinite?
Oh.
All right. So we can have one answer. We can have no answers. We can have infinite answers. Okay, that's what we're looking at. Today is a simple graph. Of course, we are going to throw story problems in there for you, but it is a simple graph. So what's the easiest form of a line to graph? Slope-intercept, which is y
equals mx plus b.
Okay, we're going to change every line into y equals mx plus b, so it's easier to graph. When we graph, where do we start at? And where the b? The b. We start here, right? Because it's your what? Y-intercept. And then we graph the slope, which is your m. Okay, so when we look at these two lines here, do I have to do anything to the first one to graph it? No, because it's in that form. Where do we start? -4, then we go. All right, now if where they cross is extremely important, is there any way to draw this without a straight edge? No, you have to have one, because their intersection is your answer. If they're not straight, it does not work. Straight edges are over there if you need one. Say it again. Did I go down? Did I not go down 4? Oh, I did I? Okay, go down 4. Up. What's my slope? Up 3 over 1. So up 3 over 1, and I'm going to do it a couple of times because I can't use a straight edge on here. Yeah, you just keep going up 3 over 1, and it gives you your line. Okay, draw your line perfectly straight.
That's pretty good.
Not bad for me. I agree. Okay, is the next line ready to graph? No. What? We do. What form of a line is this?
That's
Standard. Okay, got to solve for y, so who leaves? Okay, so I subtract the 3x. I'm going to do this wrong, and I want you to tell me why it's wrong, but it happened on the test a ton. I got 2y equals 3x minus 10. What's wrong? Why? Yeah, the 3 is negative and the 10 is positive. I had this all over the place. Be careful with your negatives, okay, people? So negative 3x plus 10. Okay, am I done? No. What do I have to do? Divide by 2. So y equals a negative 3/2 x plus 5. Where do I start? Then I go over 2 and draw your line. Okay, where do they intersect? At point 2, 2. That intersection is your solution or your answer. So the solution to this problem is this point, and this point is x comma y, right? 2, 2 in this case. What's on 4?
Mine's not even on the line. Well, I mean,
Oh, 3 over 1. There we go. Oh, that was painful. Are we good? Okay, next. You have I think you have 2 practices, actually. Just one? Okay, practice. Check with your name. What do we have to do to graph him? We we have to subtract the 2x. Did everybody do that? Did you get y equals negative 2x plus 3? Okay. So, negative 2x, because it's going down, make sure you got your negative in the right spot. So we start at 3, then we go down 2 over 1. Draw your line.
How many times do we need to dot?
Oh, I missed. Dang. Couple. All right. Next one. Do I need to do anything to graph him?
No.
Nope, he's ready. So we start where?
5.
What, Jacob? Nope. Okay, we go down 5, then we go what? Up 1 over 1. Oh, I missed that one too. I am not doing well on this graph. Okay, where they intersect is your answer. Now, are we exact graphers? No. So, could we have different answers? We can technically. And because of that, as long as your answer matches your graph, I will take it. All right? As long as your lines are graphed right. So, like here, this one here, like for me, looks like it's 2, negative 2 almost. Fair enough? All right, yours it probably should have been over here. So it probably should be, this looks like this should be this way. Probably 2.5, negative 2.5, maybe. As long as you're within the general vicinity and your point matches your graph, you are right. So could this whole row have different answers and all be right? Yes. It's going to happen, especially when we graph.
What if mine's not even on here?
Yep.
How far can you be?
Off. Okay, if I'm giving you the grid, I want it within 1. Okay, on the next ones, I thought I changed the graph, but I didn't. There's no grids. You're going to be off by a lot. Like, you might be off by 2 or 3 because there's no grids on them. You'll see when we get there. As long as it's close and the lines are graphed correctly, I will take it. Make sense? All right, next, story problems. Now, how many lines do we have to graph? Girls? Separate these two. Don't care. All right, we have to graph 2 lines. That means for the story problems, I have to get 2 lines. All right, before, how many lines did we always get from our story problem? 1. So the same thing, except there's 2 sets of information, you have to pull it out. The trick to reading story problems is to read the last line first. It usually tells you what you don't know, what you're looking for. So you look, how many boys and girls can you invite? What am I looking for? How many boys and girls? So what I don't know is the number of boys and the number of girls. It's where I start. It's a clue for me to help me read my story problem better. Good? Okay, so I have boys and girls. I let boys be B, girls be G. I assign my variables. Okay, now we're going to read the problem. Are you ready? It is, you are having the 16th birthday party. Does anybody care? Nope. Nope. Could care less that you're 16. Maybe that you're having a birthday party, but not that you're 16. Your parents have informed you that you can invite 16 people. Is that important to you? Yes, so I need to write that down. 16 people. But I know I'm looking for boys and girls. So what do I know about the 16 people? The what? Say it again. It's boys and girls, right? So I know in my mind that that's made up of boys and girls. Agreed? So I'm going to write that down just so I know it. Okay, next thing I know. Okay, Mom set aside $150 for you. Fair enough? Okay, you were foolish and went out and spent $60 on decorations. Nobody cares about your decorations at your party, people, but you did this. So, I have $150 total. I spent $60 on decorations, but it looks really cute. All right. Next, it says you have $5 to feed a girl and $7 to feed a boy. Do I need that? Yes. Yeah. All right. Well, this is $5 for a girl and $7 for a boy. What do I need from up here? I need to know how much I have left so I know how much money I have to spend on food, right? So here, I have to take the 150 minus 60, and I get $90 for food. Do I care about the 150 and the 60 anymore? No, because I've already used them, right? So they are now off of my list. They are unimportant. Good so far. Okay, your next job is to group your information so that you can create your equations. So what goes together? What's alike up there? The money. Who said that? That was right. Your money is good. So $90 for food, $5 and $7. That's all the same type of information. So that goes together into one equation. Well, how would I write the equation? Leah. How? No, I have to use B and G because I use B and G for my boys and girls. But you're right, it's like an X and Y.
Nick Erickson, report to the office.
Okay, say it again. Nope, I don't use 150B because 150 was my total, and I already subtracted out 60, so he is no longer in my equation.
Oh, would it be 5 and 7?
Yes, I have to do something with the 5 and 7. What do I have to do with them? What are you thinking? Ariana?
7B plus.
Yeah, it's how much this is today for a boy, so that's 7 for the boys, plus 5 for the girls, and how much total do I get? $90. So 7 for the boys, 5 for the girls, and I have a total of $90 to spend. All that information is the same, so it goes in one column. Okay, are we good? Okay, can I use that again? Nope, that's done. I've used it. So he's finished, I got my equation. But I still have this 16 up here. How am I going to use this 16? Say it again, Leah. Yeah, so what do I have to do with the boys and the girls?
B plus G.
See, I got to add them, because you take the boys plus the girls, and it tells you how many people are at your party, right? So B plus G is equal to 16. Second equation. Good job. So now you've created the two equations for your lines. And where they cross tells you who you can invite. All right. So first one. Okay. On my graph, which one's X and which one's Y? Alphabetical, because they don't matter. So boys is X. So boys is X, girls is Y. I know she printed it wrong. So watch mine, because you cannot see yours. All right, so I have boys plus girls equals 16, my first line. I have to solve for your G. G, because that's your Y. So you solve for G, so you subtract your B. Can I graph that? You can.
Yes.
Where do I start?
16.
Go up to 16, and my slope is down 1 over 1. Draw my line. So this is the boys plus the girls graph right there. Everybody good? Okay, now I got to do the money graph. So you're going to subtract who goes away first? 7B. And then I'm going to divide by what? Divide by 5. And I've got B equals negative 7/5 B plus 18. So you start at 18, go down 7 over 5. Where they meet is your answer. So I know you can't see it, but it's right here. And that's 5, 11. So 5, 11 is where those two graphs meet. What does that tell me? 5 what? 11 what? 5 boys and 11 girls. So I can invite 5 boys and 11 girls to my party for that amount of money.
Oh, wow.
Making sense? Say it again. Okay. That's the only one that gives you spent exactly $150. That's the only one that does that. All of these, technically, this is all shaded, which we'll learn later. So you can spend any combination in here. So like I could invite 12 boys and no girls. I could invite 15 girls and no boys. I could invite, what's in here? 4 boys and 6 girls if I felt like it. I can invite any amount in this area. But to spend exactly $150, it has to be this and have 16 people. To have exactly 16 people and spend exactly $150, I have to invite 5 of them. Okay? All right. Now, you have another story problem. I want a TV partner, so work with partners. Now, these are the clues. This is another type. And you've done it before. If you look on the board, number 2 of 4.1, it costs $30 to get into an amusement park and $5 per ride. It's that type of story problem, except now you have 2. So remember, you read the last line first to figure out what you don't know. And there's 2 things you don't know. And then read the problem to figure out how to pull it in. Okay, talk to your partners and get that done. Don't know side. This is what I should see. I don't know how much money, and I don't know how many weeks, right? It's time. And if you're going by X's and Y's, time always goes on the X. So this is your X, and your money is your Y, if you're doing X and Y. Okay, what do you know about Joe?
As 15 says
He has 14. He saves how much a week?
10.
$10 per week. Okay, what do we know about Josh?
That's 26.
Has 26. What's he save?
7.
7 per week. Okay, how do I write that into an equation?
14 plus 10.
So y equals 10x plus 14. Okay, there's Joe's. How do I write Josh's? 7x plus 26. Can you graph them? Absolutely. This is not any different than what you've done, except now there's 2. If I had said, Joe has $14 and saves $10 a week, tell me how much money he has, you would have written me an equation. Nothing has changed, except now it has doubled. Yes, you can do this. You just have to think about it. With a smile. Okay, so we start at 14. Go up 10 over 1. Draw your line. Since we're estimating, are these going to be pretty? No. 26, up 7 over 1. Draw your, oh, that's really bad. Okay, so mine looks like it intersects about here. So mine is 4 and 50. So mine is 4 weeks. They will have $50. Okay, is yours going to be different? Probably. I've done this 7 times today. I've had 7 different answers. Yeah, I've had 3 and 45 usually is what it turns out to be. What do you mean it doesn't touch? That is half.
Those are 50. I found mine. To me, it looks like it needs it.
So are any of you going to match me? I hopefully not, because my lines are really crooked.
Yeah.
But you use straight lines, and yours should match it better.
Okay.
Okay? Yes. So should you be close, or should we be in the general vicinity?
Yes.
Probably somewhere between 3 and 4 weeks. Somewhere between $30 and $45 would be my guess. Everybody, somewhere in that area. Okay, you're good. Yep, Jacob? Okay. Yeah, I take that. Now, just going over this again. If I have 2 lines that intersect in 1 point, how many options do I have, or solutions do I have? 1 solution, and it's the point. It's an X comma Y point. If they're the same line, how many points do they have in common?
Infinity.
Infinite. So your solution is infinity sign. Okay, if they're parallel, so they have the same slope.
No solution.
No solution, so I should see no solution. Okay, so you're either going to give me a point, you're going to give me an infinitive number of options, or you're going to give me no solution. Okay, now you have two graphs. They are either 1 point, no solution, or infinite solutions. Figure out which ones they are and answer the question. Talking about, okay, up here, this one here, what'd you do first?
I don't even know where to check.
X plus y equals 5. What did you solve for?
What?
Why? How'd you solve for it? Subtract x. So who's negative? The x. So it's negative x plus 5. So you start at 5. 5. Go down 1 over 1. Draw your line. Okay, everybody good? The next one is the one that a lot of people were making mistakes. So 3x minus 2y equals 20. Who'd you subtract? 3x. So negative 2y equals negative 3x plus 20. Then what? Divide by negative 2. What is a negative divided by a negative? Positive. It is not a negative. All right? That was happening all the time. So this is 3 over 2x minus 10. I know you're short 3 lines, so draw your 3 lines on. Negative 10, then you go up 3 over 2. Draw your line. Okay, mine looks like it intersects at 1, 2, 3, 4, 5, 6, negative 1. How close are you guys?
I'm negative 1. I don't know.
Not negative, you're just above.
I don't know if this looks right.
Wait, go down 10.
I did it by 2.
Did you go by 2s on the first graph? Yeah. Yeah.
I got 5 negative 1.
Yeah, it should be roughly like that.
What? Shrug.
Draw your lines where they intersect. Do your next one. Next one. So the next one is what? Infinity. Yes, it is consistent. Dependent. Up 5, down 3 over 1, right? How'd you solve the last one?
Wait, is it? I did the.
Yes.
I looked at it, it was the same.
Oh, I did it backwards.
Subtract the 9x. 3y equals negative 9x plus 15, then what? Oh, shoot, 3. I can write. So y equals negative 3x plus 5. It is the exact same line. Yes. Good job. All right, now the last thing we got to know is your set builder notation. Now we've talked about set builder before with one variable. Okay, and do it with 2 also. And it means the same thing. We have all that extra stuff we don't need. So if we have the set containing the point xy such that, remember this line means such that, y equals negative 3x plus 5. What part don't I care about? The x and y. We only care about the part after the such that, just like before. Nothing has changed. It just looks funny. Nope. It's just there as another way to write. Remember, it doesn't mean anything. Well, it means stuff, but nothing important. Okay, go. One last line.
So this is the same thing?
Yep, you have to tell me if it's infinite, no solution, or a point. Same thing. Graph it again.